So CuNim, at CuNim, people had talked about building private hangars for years, decades before I got there. But the problem is that without knowing that you can get a long-term lease on the land at the club, it's hard to justify putting up a $100,000 hangar, pouring cement, building a big steel building, getting crews in to do that. Instead, well, we just end up putting our gliders together every day. And for me, that wasn't really an option, because I got into gliding because I have a sore back. So getting a big, serious 2-seat motor glider and putting it together every day, that was just a non-starter. So we started from a point of view of what's the cheapest hangar we could build that you almost don't need a lease on the land. If you had to walk away from it next year, that would be okay. And how can you build a hangar that doesn't suffer from club politics, where there's no possibility of hangar rash, because that hangar is just for me. So today we're going to go through the design that we came up with over a few iterations for what we call the CuTee, which is the CuNim T-Hanger. So I find it helpful to start with the top view of this. So let's get a glider and a fuselage. It's not a very pretty looking glider. I'm not much of an artist. So here's a wing. And now basically we wrap a building around this glider. And so you can imagine that we put some posts here, posts, posts, posts. And now we build a little building to hold the wings.
Chester, how come there isn't any posts in front of the wings or at the front of the building?
The problem with hangars is that they require a door in front of the hangar. And a hangar door, which is 50 or 60 feet wide, ends up requiring a huge building to hold it up. And it costs $50,000 or $60,000. So our approach on the CuTee instead is to build a building where the whole front of the building can be opened, and then you can pull the glider out. So now this means the problem is that we have a whole building around here, and we have to somehow support this from behind. And this building over the wings, which is not remotely to scale in actual reality, glider wings are way longer things. Somehow this all needs to be supported from behind and from the ends. So basically start with measuring your glider and decide how wide does this have to be. Keeping in mind that when you're putting your glider inside of here, maybe the wing's going to go down, and this means that your tail will lean over this way. So it needs to be at least 1.5 feet wider on the inside, and you need a little bit of extra room here, and you need a little bit of extra room for the nose, and maybe you want to build it big enough so you can sell it to somebody else later. So this is the basic design measurements, is deciding how big this needs to be. If you build it big enough to fit the biggest glider in the world, it's not going to be very cheap. So from the side view, we'll just draw this again. So we'll start with the tail. I think this is a Blannock, maybe a Grove. From the side view on this, we have a post. We have a post. This is the ground. This is all made out of wood. So we sink the post down into the ground. And now we need to put a building, an enormous cantilever structure in front of, over the the fuselage, the wings and forward. So we need to put a few more posts in here. And then we need to extend this down to the nose. And we need to bring this back so that the aileron doesn't hit this beam as it comes back into the building. Throw a few more beams in here. Another beam in here. And that's our basic shape of our building. I'll just flesh this in a little bit more to give you a better idea of what the actual structure looks like. So, as you're beginning to design this, I found it useful to start from how high is your aileron. You assume that your main gear, where this sits, this is the beginning of your building. So this would be a few inches above ground, so you can throw in a bit of a gravel pad for it. And let's say that the back of your aileron is, say, 36 inches. So we might want this point right here to be, say, 39 inches. During the construction, we found it makes everything a lot easier if you use exactly the same angle all the way through the building. So on our construction, we built everything 4:1. So this is 4 inches of run for every 1 inch of rise. And since we've decided right here how high this needs to be at this point right here to clear the tail as it comes in underneath, I found at least 6 inches of height over the level height of your tail with the tail dulling on is good. So basically, you take your 39 inches, let's say it's a 2-seater, so typically we'd have to be about, say, 13 feet out. And just take this 39 inches, bring it up, and this is going to tell you the height right here, which you're going to get. So basically, you may have to move this up if you want more height here in order to preserve the angles. And then, once we have enough room for the aileron and for the elevator to come in underneath of the beam safely, now we come back over here. So essentially we're going to double this height difference again through here, and this gives you the height to the top of the building. And now we know how much room we want from the back of the aileron to the back of the building to the end of the tail. So we can figure out how far down we're going to end up, and then we need to make sure that we have room for the tail underneath of here as well. Keeping in mind that you need a little bit less wiggle room. By the time the airplane is back in the building like this, you're not going to be able to drop a wing, because the wing will be held in place at this point. But you still need to make sure that you're not going to hit anything with the tail by the time it's back in here. So really, in the end, we come up with this height, we make sure that it cooperates with this height, which gives us this height, which gives us this height, and then we just make sure that we have room for here, here, and here. And we like the 4:1 height. It allows the snow to run off in the winter and not just pile up on the roof. And compared to a 3:1 roof, it's nice to work on a 4:1 roof when you're putting on the metal. It's just not so steep and it feels a little safer to me. So now we're going to get into just some more of the detail of actually how you build this. So you've decided at this point on your posts. We'll make this one with 3 posts. I find that these posts should be about 5 to 6 feet apart. So this means for a single seater, you can get by with 3 posts supporting the building. And on the main fuselage building with a single seater, 3 posts, with a 2-seater, 4 posts, and say 5 to 6 feet apart. But now you know basically what your distance, your lengths are going to have to be, and you can go out and you can stake out your building. Continues to be a very short wing glider in my drawing. And we will explain some of these extra posts that we have here. So this is all the posts that you need to basically set in the ground in order to build your building on. So you can go and you can tap the stakes into the ground, and you call in a bobcat, and he augers a bunch of, say, 8-inch holes down 4 feet. We find 4 feet is a good depth for preventing the building from moving when it freezes. 4 feet should be below frost pretty much everywhere. And as soon as the bobcat shows up and augers all the holes, you discover that you don't actually know where your building is supposed to be, because you had all these stakes driven in at exact points, and now they're all gone, and you just have a bunch of holes in the ground. And this is really bad. I made this mistake with my Arcus hangar, and it was a terrible mistake to recover from. So what you need to do is you need to realize that each one of these is going to be filled by a post. So if we zoom in on this post right here, you're going to end up putting in a big square post into a round hole, and your X, where they augured, is right in the middle, and now you need to get that positioned in there so that you have posts exactly where the X's are. If you're prepared and you think ahead, what you do is you set ahead of time little stakes out here so that you can run a string along the edge of this post. So you know how big this post is going to be, and then you put a little stake out here so that you can pull the string after the fact, which runs down the length of the building for setting your posts in. So the trick is, before the bobcat shows up, you have to put in extra stakes in order to pull strings. And if you're really well prepared, what you've done is you've gone and you've set these back, say 1 inch or 1.5 inches, and so what you can do is you can attach a 2x4 to the side of your post when you're setting your post in the hole. Because what happens if you don't have this little spacer in here, when you put this post in, it will push the string over a little, and then you put your next post in and it pushes the string over, and as you move down the string, your posts push the string out, and your building slowly walks out this way. Whereas if you set the string out a little distance and then remove the spacer after you've set each post, then you will end up with a straight line of posts. But the big thing is, remember to set these stakes all along the outside of the building so that you have this extra reference information for where the edge of the post needs to be. So you can put those strings in after. And make sure the bobcat doesn't run over the stakes. Another important point for these post holes is you need to dig out all the loose dirt. Eventually, after it's augured, they're going to drop in posts. And if those posts have any loose dirt underneath of them, they will eventually settle on that loose dirt over time, and your whole building will become crooked. So you need to make sure that someone digs out all that loose dirt, and it's not normally that much loose dirt, and that you pack it down nice, and if you want to be fancy, you throw a shovel full of gravel in the bottom. Preferably a gravel which will compact, like say a 3/4 crush, which is a mix of rock and dirt and sand and lots of stuff like that, so it packs down really nice. So you have all your holes augured at this point, and definitely make sure you take the time to get these stakes exactly where you want them. Like, do your diagonals, make sure it's really where you want it. In fact, you can even drive the stakes in, and then you can push the glider back into this forest of stakes, and you can think about whether your glider is really going to fit in there, as just a sanity check. So once you have these holes and you have the strings, now you're going to drop in your posts, and we'll talk about that, about making the posts. But when you drop the post in, basically what you need to do is you need to make sure you have this hole in the ground and you have the post in there, and then you have a string this way and a string going in along there, typically. And so you're going to need a few helpers, at least one, and basically you'll hold the level on this side and you'll hold the level on this side, because you need the post to be vertical and in both north, south, east, west, and you need the post to be on these strings, but not pushing the strings over. So there's a little bit of fudge work to it, and it definitely helps to be patient with this. And then once you get it more or less positioned where you want, then you throw in a little bit of 3/4 crushed gravel. You can pour cement if you want, I just like gravel, and cement looks like hard work to me. And then you just need a few tamping bars, and you can tamp it. If you need to move the bottom around a little bit, you can tamp the gravel on one side and that will push it over. But just take your time and make sure that you just add it 4 or 6 inches at a time, tamp it, and by the time you get up to the top, it should be great. And in fact, you can even set a lot of the posts with just half or 1/4 full, and then step back and make sure that everything is really the way you want before you fill them in and tamp them in the rest of the way. Now, building the actual posts. For this, we took a cue from how they build barns at this point, these wooden structures. So if we look along the shape of our building, which is roughly what the glider is going to be figured out, it's impossible. And this is a really heavy post and expensive. So the better way to do this is to build a post laminate. So if we take a look at this post from the top, instead of making a solid wooden post, instead what we do is solid like that, like a 6x6 post. Instead what we do is we take, say, 3 2x6s and screw them together to make a large laminated post. So looking from the side, typically the middle part of this will be high. We'll take a long 2x6 and then say a shorter 2x6 and a mid-height 2x6, and you'll glue and screw and nail these together. Make sure that these are or a 6x8 post or whatever you want to make. By just building this ahead of time, you can prefab them, and make sure that this wood you buy for this is preserved, and proper preserved wood for putting in the ground. So you want to make sure that it has those needle marks where they inject poison into the wood. And all the posts will end up being the same. So you can just make a lot of them and not worry about the height that's required. Not worry about the final requirement, because you're only solving the post up to somewhere this height. So you get these dropped in, they're much lighter that way, and then when you build the rest of the post on top, you can use cheaper wood, which is not preserved. So we've gone and we've made one of these little preserved posts that we've dropped in here. And once you have these posts set in, what you will do is you take a laser level and you position your laser in the middle here, just get it leveled up, and now you can go and you can shoot and make a mark at some arbitrary point And let's say that we've decided that the height where our wheel sits on our glider is going to be 0, which is somewhere about right there. And so we're going to go around, we're going to make a mark at, say, 40 inches, which just happens to be where our laser swings across. And then we go up to every post and we mark to 40 inches. And at that point, you can calculate how much higher each of these pieces of wood has to be in order to get to the height you need. So now you can go to each one of these and you can work out that, because these are all going to be arbitrary heights, you work out that how high this one needs to be, this piece of wood needs to be, and how high this piece of wood needs to be, how high this piece of wood needs to be, and you can set them all up top, make sure the angle is what you want, make sure they all work out to the same height, and then you basically glue and screw them together. And at that point, you just have this perfectly well-behaved set of posts with the right angles on them, and you didn't need a crane to put your posts in the ground. So that gets us to here. Of course, there's nothing else on there, but that gives us our post to this height. I guess these are down below ground. And now we need to start putting up our cantilever beams. So whatever height you had decided that your wing was going to be at, you decided that there would be a particular height that you wanted the beam to start at. I guess it doesn't actually look like this, it's actually like that. So what you can do, depending on how many helpers you have, if you don't have a huge number of helpers, you can just cut a small wooden block that you put in here and just screw it on the side of that post. And now when you lift up this beam, it can sit on that post and you know that it's exactly the right height that you want it. Another great help, out here you're going to have some posts which are down in the ground, which you're just going to use for setting your doors on. You can, on these posts, you can also put in a support, and on this support you can mark the exact height that you want the beam to be, and then you can just use that as a temporary support. So you can take your first beam and you can lay it on there. It doesn't really have to require very much physical strength at all, and just a good step ladder. And at this point you don't even need a step ladder because this is all just working at normal lifting height. And now you can tack these in place. And for tacking these, I don't really trust the normal construction screw, because people are going to be standing on this, and if it broke it could really hurt somebody. So for this we used a much more serious structural screw like this. And they're not super cheap, they're about $1 each, but you end up needing 100 of them or something, so it's not too terrible an expense. And we tack that in place. And then we can just start going at this point, but in practice we now need to add this beam. This beam does not exist yet, and this beam right here, this joint up at the top, is actually quite difficult because we have pieces of wood which are going to get laid on there, and we're going to get pieces of beam built down to there. And so this one is quite difficult. Sheldon will add some pictures in to show how to basically overlap all this wood together so that the bolts can hold it all together. But once you have this beam up, you can lay 3 of these beams in and you just build them in place. Everything is just built from 2x6s. So you just put them up and put a little bit of glue and screw them in, and put the next one, put some glue, screw it in. And so once you have this beam up top built, and now at this point we can add these other beams which go down, and essentially you just follow this slope down until you either hit the ground or you hit the back of the building. Some of these beams you may need to make a joint, which is annoying, or you have to buy really, really long wood. We were fortunate to be able to buy wood direct raw from a sawmill. And each one of these beams, as you throw it up, we're just tacking it in with screws. And because they're all spaced evenly, you can just make spacers ahead of time and screw them in. And you may even choose to just leave them in place and just make them out of scrap pieces of wood. So this is really quite easy work. And basically we'll just be, even though my drawing doesn't show it, you'll just have the same length spacers everywhere. Now, you'll do the same thing on the inside of the building because we have exactly the same beams on the other side of it. We have beams on the outside that are sloping up like this. We have beams on the inside of this. And then we do the same thing here. We have beams here. We have beams on those posts as well. So it's quite strongly built. And now once you have all of that built, you can build the back wall. And the back wall is really simple. Just screw 2x6s along the back to hold on some tin. And now you can build the joists. So for roof joists, rather than getting custom joists made, we just used 2x8s for a 2-seat building where the building is 13, 14 feet wide. And we use 2x6s for buildings for single-seaters. So what we used for these is we just used joist hangers, standard joist hangers, and we would just connect them onto this beam. It's really easy on the back because you just have a solid beam to connect to on the inside. It's a little bit more tricky here because you have to fit your joists in amongst these beams coming up, and we'll have some pictures of that as well. Or you could choose to just add a spacer in there and then screw your joist hangers through that spacer to get it solid. So that covers the back. So on the main building, I guess we'll just go back to this picture quickly. On the main building, we have the advantage of this huge storage for the back of the fuselage that can be used. All these posts, all this building back here can be used to support the building front of the ailerons. We don't have this on the wings. There is nothing on the wings behind the ailerons, at least not on my airplane. So what we do on the wing box, at the back of the wing box, it's quite easy. We can just put some 2x6s along these posts, and we can basically just make a little wall at the back of the wing box right here. You can just put a wall which can be used to hold up the roof, because our wing box just has to be a little building stuck on the side of this, on the side of our building, which holds the weight. So we have the fuselage, we have a great big glider wing, and we have post behind the wing, and there's our main wheel, and here's the ground. So behind, that's easy enough. We can have a post down here. Out past the end of the wings, we can have a couple posts. That's super easy. Behind the wing, we can put another post. So the back of this building is easy enough. And then we can just throw a 2x6 in behind this. Put a 2x6 behind this. On my building, we chose to step it up right here. Although it looks cool, I'm not sure it's particularly useful. And then we just chose to staple OSB behind this to close in the back of the wing box and give it a little bit of rigidity, because we're still supporting a roof over the wing at the back of this. The challenge comes from supporting the front of this roof over the wing. And because we can't put a post here, because our wing has to go through there. So what we chose to do here was, remember that this whole roof on the wing box also slopes behind. So we have we built a beam up here, and this is a 4-to-1, so we're about, say, 12 inches higher. So we put an enormous 2x6 in front, connected to the front post of the wing box, and then we just put a 2x6 down here, and then we just stapled OSB front and back on this. Made sure the connections were really, really strong. We put OSB behind it. So basically we use a huge box beam, over 24 feet long, made out of OSB and 2x6s to support the front of the roof, to support the wing box over the front of the wing. So this, in our drawing right here, we have our wing in here, and this whole box beam that we're talking about is just right here. So basically, wing is here. So we would join, one beam would come in here, one beam attaches here. We reinforce this area a little bit, stiffen it up. And it's proven to be immensely strong. But one key element to this is that we don't make this a huge roof. This roof is only about 5 feet front to back, so it's not terribly deep. So the wing box has been quite straightforward to build, but you do have to be able to get really long lumber to build it, or you have to be comfortable making joints in there somehow, which would be a little bit nervous. The bottom of the wing box here, we just built a small floor. Basically, there is a post in the ground in front of the wing, so that we can just run 2x6s across and then put little 2x6s to support it. And then we just close that in with OSB on the top. And this just allows the wind to blow in underneath. It means there's no dust entering from underneath. So on our original T-hanger designs, we made the mistake of building the glider up on a 2x6 floor. And this is really quite tricky to do, because you need to be able to support this entire floor from the sides of the building. So you have to make an entire floor connected to these posts and connected to these posts, and then keep it all up off the ground so it isn't pulling moisture out of the ground, build it all out of preserved wood so it doesn't rot, and then you end up with your glider 9 inches up in the ground from the grass, which is quite high. And so it makes it hard to push uphill into the hangar, and when it rolls downhill, it's way too exciting. So our solution on the latest 3 hangars has been to just add a couple inches of gravel inside, and just add a couple inches of gravel inside the hangar. You can laser level it, get it roughly level, tamp it down, and then you throw a tarp over it. I mean, if you can get a heavier tarp, if you can take a knife to someone's fabric hanger when they're not looking, that's excellent. And throw a piece of fabric over it. If you want lower rolling resistance, you can just make a little piece of plywood walkway down the middle that the main wheel rolls on. It takes very, very little. All you need with the floor is you just need it to be high enough so that water doesn't pour inside and make a lake inside when it rains. And unless you're building it in the middle of a swamp, this is not that tricky to do. So don't get tempted to build a big fancy floor. And the other key element is building the doors. So like if we take the front of the building, and this would just be the face of the cantilever. And then we have a few posts in the ground. So your main glider wheel will just roll through the middle. Make sure you give this lots of room. You may end up installing a winch like I have, so you can walk the glider in without anybody else helping you. So give this lots of room, because it can be hard from 25 feet away to judge where the wheel is with respect to these posts. And then when it comes to actually building the doors, we found it to be really straightforward to just build it out of strips of plywood. So if you want to build a door which closes against the face of a piece of wood right here, you can just take a strip of plywood a couple inches wide, attach it right here, use screws from behind, not from in front, and then you can attach a couple. You're going to want to put a strip of like a 2x6 along here to give it really something to attach to solid. Put a couple standard 4-inch door hinges on there that hinge from the bottom, door hinges that hinge from the bottom, and then just attach this to a sheet of plywood. And after you have it screwed on to the door hinge right there, you fold it up, put a few screws in from the inside, fold it up, and now you can just take a whole strip of plywood and attach it on the outside of that. So it's all just staples and glue. So we laminate a piece of plywood on the outside of that, cut a little piece of plywood that goes in here, glue and staple. Everything is glued and stapled. You can cut the strip of plywood that goes in there, staple that, and finally, cut a piece of plywood for here, and you just make it all out of 2 or 3 inch strips of plywood. I've gone with 1.5 inch wide. It's just too weak, it likes to break. And then finally, you can release your screws that you have from behind that are set in from the inside of the building, and make sure that your door folds down, make sure you're happy with it, put it back up, hold it in place with a screw from the inside, put some tin on it, and boom, you have a door. And then you make that, you probably end up needing about 8 of them along the side of the building, but it's satisfying to build a hangar door out of $500 worth of tin instead of $50,000. So the doors are really quite similar along the wing boxes as well. This is way too long of a door to make in a single piece. It will just be much too floppy. And we've also struggled with how to overlap the doors, because of course this door folds out. The one from the front, I think it's more clear on this drawing, that we have a door here which flops down, and then we have a door here which flops down. We have a door here which flops down. So these two overlap. And this turns out to be not such a problem, since this door is attached really low to the ground. So it flops down just basically right on the ground, whereas this one is hinged from up high. So it flops down. So basically, if you make it so that these ones go up first, the wing box doors fold up first, and then this one folds up, you end up with really a quite tight seal. I mean, it's not tight enough for a house, but it's tight enough for a glider barn. And these are all built from the same principle. An important point though is you have to give some surface for the top of the door to seal against. So you may have to put a little barrier of OSB dropping down below this box beam to give something for the door to press against. There definitely is some detail to getting the doors right. So we're inside the main fuselage building for a CuTee designed to fit an Arcus. And as you can see, the whole building, ailerons finish right here, as is the back of the wing. And then everything forward of here is a cantilever, which is supported by these main wood beam posts going back, 4 big wood beam posts on each side. And of course, you have each side of the building. And we zoom in on the detail of any one of these posts. This building is built all out of rough cut lumber. So these 3 side by side that you see right here, this is 3 rough cut 2x6s. So in order to get this 6-inch width with dimensional lumber, you'd have to go 4 wide. And then as these posts come up, the original post that we made had just 3 of these brown ones that you can see here. I guess we're covered up by some foam here. Maybe it's more visible on this one right here. So we would have originally tamped in and built 4 of these posts to roughly any height and dropped them in here. And then after they were positioned and we had marked our reference height for the whole building with a laser, you can see the original mark right here. Then we cut regular lumber and screwed it on to get us up to the full height. So as we, looking forward, we have up here, we have the main beam along the top of the building going front of the, it's part of the cantilever, is 6 inches wide. And then this joins right here with these large 1/2-inch lag bolts. All these connections are joined with 1/2-inch lag bolts. And then we have 2x6 beams which drop back to form the other part, the other half of the triangle. And then these posts are, there's 4 main beams that work their way back into the building, and we just slope them back to keep connecting them on the posts until we either run into the ground or we reach the back of the building. And we have found this to be really quite strong. During construction, we found it very practical to use like a heavy structural type screw to hold them in place. And if it was ever tricky to get the posts on and get them supported at the right height, then we just cut a little spacer beam that we screwed in here. And more details here. So the roof is just, this one we did it with 2x6s with a 2x4 stapled along the bottom. On the newer designs, we decided to use 2x8s instead, because we find on this building here is over 13 feet wide. We found that we just wanted the depth of a 2x8 to give it the enough rigidity to span the distance. Alternatively, you could just put more of them. Getting the joists, or getting the roof joists, if that's what you want a fancy name for a 2x6, getting them worked in amongst these beams that are coming up is kind of tricky. Another way of doing this, because you can see that we can't really put this beam right here because it's not even. We have this one coming in. So another approach to that would be to just cut a spacer and screw it onto the side of this beam, and then you could join, you could come in flat and you could just mount your roof joist wherever. Just details one way or another. And on the outside, we actually had to create those spacers to give the tin a flat surface to screw to. So that would be something to think about. So from a design principle, one of the very first items to consider is how high you want your aileron, where your ailerons are coming in back here. So you can see on the foam where the ailerons of the Arcus press against this foam. And so then we added about 3 or 4 inches right here in order to get a little bit of space. We don't want it too tight. Wood is unforgiving compared to carbon fiber, so we don't want to scratch that. And this whole building, all the angles we have set them at a 4-to-1 angle, just to make it easier to do the math and cut the do the cuts. So basically we come forward at 4-to-1 until we're up here. And the critical point right here is we want this beam right here to clear the tail. And unfortunately, I designed this building before the Arcus had arrived, so you can see that my tail does not actually clear the beam. So I have to be careful when I pull the plane through here that I don't let the wing down and hit this with the tail. You can see there's a interference point there. So overall, this whole building should actually be about 3 or 4 inches higher. So the second building that we built for Arcus is we did actually build it higher. And then from there, from this point, then we continue back up at 4-to-1, and that determines the height right here and at the very top of the building. And now we drop down at 4-to-1, and somewhere back here, we need to make sure that we actually have room for the elevator when the wings are level, to make sure that the elevator will not hit this. It's not as tricky because at this point, your wings are being held by the wing boxes on the side, so the wings cannot actually drop down. But this is another work design point. Another design point in all of this is that you want to make sure that if the wing goes down as you're pulling it out, that the aileron, the elevator horizontal stab will not hit these as you pull out. And in fact, I should even snip off these little bolts right here to just give it as much room as possible. And so you see that the building actually ended up being probably 1.5 feet wider on each side than the horizontal stabilizer on the Arcus. And the floor itself here, on our original hangars, we actually built a 2x6 floor, which was raised up above the ground, and we ended up with the whole floor about 9 inches above grade. And the problem with that is that now your whole airplane has to be winched up 9 inches, so you need quite a ramp coming up to the building. And as you push the airplane out of the building, of course now it wants to roll down that grade, and there's more energy there than you really appreciate. So with the latest series of buildings for the two-seaters, we basically just used 2 or 3 inches of gravel and leveled it as much as possible, tamped it down, and then covered it with a tarp. And this fabric hanger material we have here is just indestructible, but as long as you use a fairly rough, fairly tough quality tarp, it should be good. And then here, just to decrease the rolling resistance, we just have a sheet of plywood. And we tried to build these walls to keep the mice out, but it's a failure and we gave up on it. That's why we have 100 mouse traps in here. Moving on to the wing boxes. Come in a little closer, Shel. So the back of the wing boxes, this is basically just a little building which holds the wing, which is attached to this building. There are just 2 posts, so we have and then we just run 2x6s across the back of it and build a little wall that will hold up the back of our roof at that point. And we stapled some OSB on there just to make it all a little more rigid and to essentially form a large box beam on the back. At the bottom of the wing boxes, on our original design, we just extended them right down to the ground, and we ended up struggling a lot with dust in those designs because it just ends up being a solid layer of dust. Nothing grows inside the wing box, and any little puff of wind will pick up dirt. So on these, we chose to just build a little floor in there and close it in with some OSB. And now the wind just sails right underneath, and it's kind of cool looking anyway. The main detail on the wing boxes is how these wing boxes join the main building. So at the back, we just bring the wing boxes into the side of the main front support on the fuselage building. But this right here is the most critical component in the wing box. And because obviously we can't just put a post right here because the wing has to go through there. And we didn't want to try to cantilever all of this back to the back post because then we would have to put even more structure behind this. So what we've done here is we just built an enormous box beam out of long 2x6s. So there's a long 2x6 which attaches to one of the cantilever beams there, and it attaches to this post right over here, and there's another 2x6 which now runs down through here, and in order to stiffen it up and give it strength, we just glue and staple OSB on both sides of it, and it is incredibly strong. And then at that point there is just a little detail of how to build a roof inside of here, and essentially we just put another beam through. Yeah, and then you just get into basically making doors at this point and how to cover it with trim. We took a lot of shortcuts on trim compared to how you would do trim if you were putting metal roof on your house, because we're not worried about an occasional drip here and there. So the doors themselves are just built out of laminated plywood that we ripped into strips. Come on in, Shell. So basically we build the door frame out of just pieces of plywood, 2 layers of plywood, so we can overlap them and staple them together. And then we build them right in place on the building, tacked in from the back, and we screw the tin on, and it's good. So it's very satisfying to take a problem which would normally require a $60,000 hangar door and do it with just $500 worth of tin and a couple sheets of plywood. So a few more details. You'll notice these posts, we've laminated them, you know, this post, this post, this post. So they're all laminated going this way. And the reason for that, compared to being built this way, like 2x6, 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 the reason is that we're bolting through all of them. And we don't want to just bolt through the middle one, we want to bolt through all 3 and hold them together. And whereas you'll see on the wing boxes, the posts on the wing boxes, because the beams are running this way, those posts are all laminated 2x6, 2x6 this way. So that basically, because we're running screws and bolts through this way. And there's also some detail. In order to give attachment points for the doors, even though there's no posts from here all the way through here, all the way up to the front, we still built a beam which is just attached to posts way back and way at the front. And this is to just give us something to screw the doors to. And underneath of here, there's a little 4x4 that's just tamped in the ground. And there's a 4x4 here. And these are only here because if we don't have these, we have nothing to hinge the doors off of. Another point I would make is that don't feel tempted to squeeze these posts too close together, because if you are winching this airplane in and out on your own, you'll be way out on the wing, and it's difficult to tell where the main gear is. And it'd be very easy to rip your gear doors off on this kind of thing or over here. So don't feel bad if you give yourself 3 feet.